Okay, welcome back everybody to another day of listening to Miss He yapping. But today we're gonna go over for the January 2025 and also June 2024's open response. So we have already finished talking about everything in their multiple choice using our regular solving skills or using Desmos graphing calculator, which is like all the tools that you'll have in your regions. But today we're going to go over for the one that is open response, which is part two, which require a whole lot of calculation and understanding the question. Like there's no more guessing this time. All right, let's start from the one from 2025, January. This is continuation of last week's material, and we're gonna start from question number 25. All right, the graph below shows Sally's drive to the store and then state the interval when Sally's traveling at a constant speed. So in here, the keyword is constant. So we have seen this word and we know that it stands for just a number. But what does a constant speed stand for? Anytime that when to start with a unit, that means that it's going to be steady. The number's staying the same. So let's take a look. And here, we're going to have starting at the time of 0, I got no speed. Of course, your car's parking. And then 0 to 2, this is like a tiny turning point right here, is going to be a steady rising, but this is a speed is going from 0 to all the way to 5 and all the way to 10. So my speed is rising. So if you don't understand how to do it, go ahead and name some coordinate points. In here, you're going to have 0, 0, you have 2, 10. So that means at 0 minute, I'm going to have a speed of 0. And then 2 minutes later, my speed is going to be 10 miles per hour. So this is still relatively slow, but the thing is my speed is not steady. I don't have a constant speed because I'm changing, I'm having a rising speed. So I have a rising speed in here. Eventually, when I move to 5 minutes later, I got it for 35. Okay, so that means between 2 minutes all the way to 5 minutes, I go from 10 to 15 and then to 20 and then to 25 and to 30 and to 35. My speed is still rising. So when I'm reading this, I know that my speed is still changing, so this is not a constant speed. Now here I see a flat line. So in this flat line, more specifically, I'm actually seeing that my y value stays. So I have a 6, 35, I have a 7, 35, I have 8, 35, all in parentheses, of course, because these are coordinate points. And here all the way to 9, 35. I realize that in 5 minutes, my speed is 35. In 6 minutes, my speed is 35. In 7 minutes, 8 minutes, 9 minutes, my speed is still 35. So this specific interval, you can use words or you can use interval notation, say bracket 5, 9, to saying that include from 5 all the way to 9 inclusion, or you can say it in English words, say from 5 minutes to 9 minutes. So this is how you describe an interval. You can use a math interval notation or you can use English words. Now, why? So in my explanation, I just so happen to show you the whole entire thinking process. I'm actually using a 5, 35, then 6, 35, and 7, 35, and 8, 35, and also 9, 35 are the coordinate points on the graph. These are our points on the graph. To represent what? To represent that at different time, my speed is still the same. So from 5 to 9 minutes, my speed, not my speed, sorry, Sally's speed. Sally's speed is staying at what? 35 miles per hour. So that is why you know that that is a constant speed. So once again, final sentence, therefore, the speed is constant. Once again, always making a final statement, regardless what it is that you just answer, from 5 to 9 minutes. Just like that. So that's how you answer this with a complete full score, saying that, oh, I already answered each part and also give you a full reason in English sentence. Okay? All right, next one. I have a graph for x squared plus 4x plus 3. This is a quadratic equation. Once again, last week, Well, actually, technically yesterday. I already showed you guys how to do it in the Desmos graphing calculator. Here they said graph it. That's part one. I gotta graph it. I cannot skip that part. And then you say state the equation on the axis of symmetry. So this is another part that I actually assigned it in Google Classroom today, and hopefully everybody do see it. Let me pull up Google Classroom right now. It is a assignment that you should do it. All right, so this is our Google Classroom. And as of yesterday, I actually posted this work saying that doing the quadratic equation. What is going on here is you click open this PowerPoint, and then this is talking about exponential functions, quadratic, well, actually not here. Probably I was lesson planning for another day. Um, yes, I was lesson planning for another day. Let me pull it out because exponential was for today. Quadratic equation is Tuesday. Sorry, I'm mistaken. Because I remember I was doing this yesterday. All right, so on Tuesday, this is going to be something that you will see in our classroom, talking about all the characteristics that you will see in a quadratic equation. So you will see a vertex form, or you will see a regular standard form of an exponential, sorry, a quadratic equation. You'll be analyzing a domain, a range, an axis of symmetry, and then vertex, x-intercept, y-intercept, and zeros, and maximum and minimum, all of them. Okay, so what do we call it? Domain means where are your axes can be. From the most left all the way to the most right, you need to use your interval notation to describe stuff. Range, from the most bottom to the most top, you use your interval notation to represent what number you can be. Axis of symmetry, AOS, that's what it stands for, axis of symmetry. That means where is the vertex and what is the line that you create to go through the vertex that will make sure that this parabola can mirror itself, which is reflection over itself. And then a vertex means that what is the exact turning point? Where is it? After that, x-intercept, you look for x-intercept. Y-intercept is where it crosses the y-axis. Zeros are same exact thing as your x-intercept, but only the x value. Maximum, if this is a happy face parabola, then you won't have a maximum. Minimum, that means it's going to be the lowest point. Same thing on the reverse. If you have a sad face, then everything will be flipped over, and then you will have a maximum point, but you will not have a minimum point. But once again, this is just on Tuesday. You'll see it soon. But once again, our handy dandy friend is always going to be our Desmos graphing calculator. So please make sure that you know exactly when and how to use it. So once again, on the Desmos graphing calculator, that is going to be a test mode that you will have. All right. And then this is going to be here. Okay. There we go. So in here we are, if you already get the calculator or the computer, they're actually already come with the test mode and kiosk mode, so you don't need to actually select the state, but because I go on the website, so that's why I'm selecting New York State. But let's go ahead and take a look. We have x squared, and then plus 4x, and then plus a 3. You have a smiley face looking like that. All right, and then they said graph it, but the thing is I have hover over, and then you have all of these perfect, beautiful cross points. So that means on the other side, I'm going to go draw it. I have a -3, 0. I have a spot right here. But once again, all of this grid are no label. So that means you're going to label itself. So 0, -1, -2, -3. Making sure that you let the grader know that you're scale. Same exact thing here, 1 and 2 and 3. So I have another spot right here, 0, 3. I have a -2, -1, and I have a -1, 0. Now the rest don't have to be super perfect, but like you can just like make a beautiful curve coming out from here. At least makes the sketch look like, as long as it looks like a smiley face, that should be good enough. Okay, so that's my copy of it. And the state equation of the axis of symmetry. Now, just like the PowerPoint I'll show you, we're going to have a whole entire lesson on that on Tuesday. But axis of symmetry is always x equals something. And then where is the symmetry at is always going to be at your vertex. And then you have to use the x coordinate of a vertex. And here we know this is -2, -1. So as of the x-axis, we're going to have the matching number with the x coordinate. So that means x of -2. So x equals -2, that's going to be our equation. Okay, just like that. Just that easy. But again, here's just 2 points, a graph maybe for a point, and the axis symmetry for another point. Just like that. But once again, if you have a decimals graphing calculator and nothing will be too crazy, all you got to do is plug it in. Okay, next, the function is shown in the table below. This is a question that we have seen our 8th grade state test already like 4 million times. So they said appropriate value to make sure this remains as a function. Define a function. Every x, I say it like 4 million times, only have 1y. All right, so this is a definition of it, of a function, and you don't need to write it in the exam, of course, but this is just for us to remember what's going on. After that, we need to know that all of these x's can only show up once. So whatever m that I pick, I can be any value. So we can say m equals to, I go 0, 1, 2, 3, 4, 5, 6, and so I got no 7. So in here, that means this place you can choose a number 7, you can choose a number 8, you can choose a number 9, you can even choose like negative number, all of that. So all of these number are used up. You can choose like 7 or 8 or 9 or like 11 or 13 or a -5, whatever number that you choose, anything will be fine. But making sure that you don't do like me, you do one number only. So you can say m equals 7, that's it. Or you can say m equals 9, that's it. M equals 2 million, da 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 da. And then the next one they ask you for explain, so sorry. So that means this should be going here. You're going to say every x only has one y to be a function, or you can say every input can only has one output. Just making sure that never of these number are duplicated. So I think every input only has one output. That's going to be a better solution. Every x only have one y, every x only have one f of x, every input have only one output. So all of that. We have seen this like so many times in our 8th grade state tests. So making sure the sentence is going to be the one that you remember. Okay, next one, solve by completing the square. This is something that we're going to spend a day on talking about right after when we learn the quadratic equation. But before that, once again, we can actually have this using a decimals graphing calculator. So x squared, and then plus 8x, and that equals, oops, sorry, equals 33. So with zooming out, then we can see the two that's is here. So if you sketch it, this is a very zoomed out picture that is going to be something looking like that because a cross at all the way at -33. So it's very far away. So that's even further than 33. I don't think so. Yeah, it's even further than that. Well, actually, I can't tell that then. Okay, so I don't technically have that -33, but we cross in very, very bottom number. So let's take a look. I have a number all the way down there, so I can actually draw it, but I can actually have my two x-intercept. I have a -11 and +3. So I got two methods to do it. If I do choose to graph it, then I'm going to finish graphing it and write down my completing square is going to be x plus 11 and also x minus 3. This is called a factor form. So what does that mean is I'm going to have a opposite of my x-intercept in here. So if I have -11 as my x-intercept, I'm going to do x plus 11. If I have +3, then I'm going to have my opposite, once again, of another x-intercept. This rule will apply to every single polynomial in the future. So if you ever have a picture of mine looking like that, in the future. Then you have 1, 2, 3, 4, 5, and that is going to be a 5-power polynomial that apply the same exact rule. If you pretend, if you have a -7, then 7, and then 10, and then 11, and then 15, then you will write it as x plus 7, and then x minus 7, x minus 10, and then x minus 11, and then x minus 15 as all your polynomials factors, and then set that equal to 0, and then you'll be calling it a day. That was it. That's how you complete the square. But once again, this is a decimal way. This is not officially how you do it, so I'm going to write it down. This is decimals only. and you don't technically have a point. You only got like half of a point because you only got the solution. You did not show them how you solve it. Because the word, it says solve for. Once again, we have seen it before. Solve for means that I'm gonna actually show some math, show some calculation. So I have to show it. So how do I actually do it? Let me show you how to calculate this by hand. So x squared plus ax equals 33. You got to make sure that you push everything on the left side. Then you'll do a properties of equality by minusing 33 on both sides. You have x squared plus ax, and then minus 33 equals 0. All right, and then you have completing the square. That means that I'm going to make sure that everything comes in parentheses and make it look perfect. So I'm going to have a number x, and then I choose this to divide by 2. Then I'm going to have a plus 4. Completing the parentheses, I'll have a minus 33. But just now in here, I just made up an equation. I just made up an answer by dividing it into 2. So if I do FOIL it somehow on the right side, there's like rules in the future that you should understand. So if I do FOIL it, there will be x squared plus 4 squared and then plus ax. Now the x squared and ax, we have seen it literally right here. And just now I just plus a 4 squared out of nowhere. So in here I'm going to minus a 4 squared because I can't just made up number. So in here, after I complete the square, I have x plus 4, parentheses square, and then minus was 33 plus 16. I'm going to have 49. So 49. So if you were trying to, this is already completing square, so everything is done. If you decided to solve it, you will have the same answer like above. Okay, so let's see. I have x plus 4, parentheses square will equal to 49. Well, we know that 49 is technically 7 squares, so we can actually square root on both sides. So that means I'm going to have x plus 4 equals to positive and negative 7. And then at the same time, if I split it up, I have x plus 4 equals 7, or x plus 4 equals negative 7. I do minus 4 and minus 4, I have x equals 3. I do minus 4 and minus 4, and then I have x equals negative 11. Look, I have the same exact answer, just like my decimals graphing calculator show me. Look at that. I have these two perfect numbers. They're the same thing. They're matching, but the thing is, they only ask us for completing squares. So that means the purple part and the red part wasn't actually going to get you the full score, but only the green part is going to be it because you're completing square. You just finish making them a square. That's what completing square stands for. But the purple part was just to show you I do have my answer, even though that I calculated by hand. Just like that. Okay? I hope you slowly take it in. This is going to be a whole lot of concept. But if you know how to get a final answer already, like using this and this is already getting you a full score. Okay, this is how you complete the square. But if you do a factor form, you still got some points, but definitely not the full score. Okay, next one. If that happened, algebraically determine the value of x when that equals negative 22. This is a very classic BCSP. So they said when the solution, f of x literally just what the solution stands for, or y stands for. They said when the solution equals negative 22. So that means by substitution, I plug it in. I have negative 22 equals negative 3x minus 5 divided by 2. Very classic DCSP. You have this numerator in a parentheses. So how would you get rid of a denominator? Always multiply the same exact thing. So I times 2, I times 2. This is called multiplication properties of equality. Now you have a negative 3x minus 5 will equal to negative 44. Very simple. Plus 5, plus 5. This is addition property of equality. Once again, just DCSP all over again. And then you have a negative 3x stays on the right, and then I have a negative 39. And then division property of equality. Just like normal, negative 3, negative 3, and now you have your x on the right side. That turned into a 13. But as a very good mathematician, I always like to put my x on the left side, but you don't necessarily need to do it, but it's just a very good habit to practice. All right, that's it. That's how you get the 2 points in there. Okay. Next one, rationalize the denominator of the fraction and then express in the simplest form. All right, this is a very classic number is every time when you have a square root or any root, regardless what root, any root on the bottom, you times the same exact number on the top of and the top and the bottom. All right, so anything that you multiply by one this is called a fancy one that you'll see it later. Fancy one. What does that mean? This is actually called the multiplication property of identity. Multiplication property of identity. So what does that mean? It's literally anything times one is equal to anything. So that's why when we call it a fancy one, that means we can actually change it to something else. All right, well, I'm going to go cancel out the denominator. So that means I'm going to times a one that is very fancy, but the top and the bottom is the same thing. And I'm trying to match it with the denominator. So I'm going to have a square root of 2 over square root of 2. All right, what are the other fancy ones? I can be 7 over 7. I can be 5 over 5. I can be 20 over 20. I can be a million over a million. But the thing is, these are all called fancy one because the top and the bottom are the same thing on the denominator. Anything but 0, of course. And then if I decided to choose square root of 2, then I'm going to divide by square root of 2. Because regardless, top and bottom cancel out, I'll still have a fancy one. But if you multiply across just like normal, the top will give you to a 4 square root of 2. And the bottom will give you a beautiful 2. Now you can simplify. So after you simplify, you have a 2 square root of 2 over 1 because you divide by 2 in here. So final answer, 2 square root of 2 in a beautiful, most simplest form. This applies to every single one of the square root in the denominator. It can be square root of 5, square root of 17, square root of 2 million, square root of anything. Let me just give you another example. If I have 17 square root of 5, even though this number looks crazy, but once again, multiply by our same exact denominator, but also make it into a fancy one. Top will become 17 over 5. The bottom would just become a beautiful 5. Since 17 and 5 don't actually cancel out to anything, so I'm going to keep it 17 over 5, and then a square root of 5. So keep it as a fraction. That's fine. Or you can think about other things. That doesn't matter. But either this is already a good answer or this is a good answer. They both good answers. All right. So just pay attention. Regardless what square root you're getting in a denominator, you just multiply by fancy one. All right. All right, here we go. Finally coming to part 3. These are actually very heavies. They are having 4 points, and eventually at the end you have a 6-point question. Let's take a look at how to do it. So this one, Alex had 1.7 in nickels and dimes in her desk, and there are 25 coins in total. This is a very classic systems of equation. Every time they'll be asking you about like hot dogs and burgers and hot dogs and sodas and candies and popcorn and soda in the movie theater, and then now nickels and dimes. Always, always, always nickels and dimes. Let's take a look. So in here, this says write a system of equation. Again, see, systems of equation to determine both the number of nickels n and the number of dimes d. So these are the systems of equation. Always start with the bracket. The bracket tells you that these two go together. Okay, so $1.7 in nickels. So how much is the nickels? I know that nickels is a 0.05 worth of the dollar. So I'm going to have a 0.05, which is the worth, times the amount of nickels. The amount is equal to $1.7. So this is the total dollar. So, oh, sorry, nickels and dimes. We're not done yet with the total. $1.7 worth of a nickel and dime. So let me circle that together. All right, and dimes are 0.1. So that's, once again, is the amount of dollar times the amount. They literally just give you, that stands for the little d. The letter D stands for the dime. All right, I got nickels worth and, in English, the dimes worth together, $1.7. Once again, total money. Next one, they said that, 25 coins in total. I know the amount of nickels plus the amount of dime. So once again, the amount plus an amount is equal to total amount. And then we just mentioned it, the amount is 25 in total. So that's it. 0.05 N plus 0.1 D equals 1.7. A lot of times they will be like, nickels and quarters, dimes and quarters, and all of that. Nickels and dimes and quarter always got mentioned. All right, next one, they said use your system to determine both the number of nickels and dime. So in here you can use substitution. I think this is going to be the best method because the N and D are look like very much separated. So we have seen it last week in our elimination process, in our graphing process, in our substitution process. 0.05 N plus 0.1 D equal 1.7, which is the amount of dollars. And now N plus D is equals to 25 in the amount of points. Now this one look very much isolated, very close to isolated. So I pick either N or D, doesn't matter. So if I say N is equal to 25 minus D, okay, that means in here, there's going to be plug in to anywhere that is having an N. So when I buy replace and I buy substitution, so I'm going to say 0.05 multiply, that's not N anymore, now it's a 25 minus D. After that, plus 0.1 D equals 1.7. All right, very classic DCSP. So D, distribution, 0.05 times 25. I don't know what it is, but let me use a graphing calculator. And that gave me 1.25. There we go. So 1.25 minus 0.05 D plus 0.1 D equals 1.7. C, combine like terms. I got these two things are like terms right here. So 1.25 and then plus 0.05 D equal 1.7. I wasn't going to be so sure, but let me double check. Negative 0.05 plus 0.1. Yes, I was correct. And then pick on small variable, there's no S, so I'm going to start with P. Properties of equality. Which one? Subtraction property of equality. Minus 1.25 minus 1.25. I have 0.05 D equals to 0.45. Let me double check my math. Always don't be so sure in the regions. Always double check your answer. 0.45. Good. And then the last one is division, property of equality. Divide by 0.05, divide by 0.05. Now, in their regions, if anything you write out of the box, they won't grade it. So making sure that you write it on the right side. D equals whatever it is. So 0.45 divided by 0.05. You have 9. So dimes, you have 9 of them. As we mentioned on Tuesday, that every single time when you see a substitution, you grab this and plug it into the first equation that you just finished calculating. So that means I'm going to have N equals 25 minus 9. Simple, which is going to be a 16. Double check my math. Regardless how simple it is, always check your answer. All right, there we go. So that's how you have dimes and nickels. But to be more safe, definitely always find out answer inside there are 9 dimes and 16 nickels. But once again, do not be like me and write outside the box. Don't do that. Make sure everything is nice and neat inside the box. Okay, so once again, this will be accessible in our Google Classroom, making sure that you go online and download this file. Okay, so let's see, write a linear regression equation. This is going to be next Monday, which is June 1st. We're going to go over a lesson on the calculator for TI, but without the TI calculator right now at this moment, I'm going to use the Desmos graphing calculator. So you can make a chart, use the table, and then you have the X and Y label very clearly. So I'm going to punch in all of these as a X column. So 135, 147, 150, 144, 146, 153, and 143. Double check if you type it wrong. 7.5, 812, 866, 761, 25, 863, and then 737. All right, with that, I click on, I'm gonna go zoom in, zoom out actually, because these numbers like huge. Let me set my domain. I don't want to see that. Probably -1's good enough. Domain probably 150. No, 160 because 150 is my smallest number, greatest number. I don't technically need to see the negative. Probably let's start with 100 and a positive. And negative will get me 7. So let me set 1,000. Okay. So I have all of these black dots right here, beautifully lined up in here. So let's see how it goes. It said write a linear regression equation. That means they take a guess about what the linear equation is gonna be. And then rounding all values to nearest 10. When I click on the linear regression, they actually do give me the equation right here. So all I gotta do is just copy it down. But once again, pay attention, they said nearest 10th, which is the first decimal place. So y equals 9.1x minus 527.556, I'll say 6. All right, so that's how you round it to the nearest 10. Related correlation coefficient, which is right here, R 0.9022, and they, again, nearest 10, so 0.9. Yep, that's it. State what correlation coefficient just suggests about linear fit of data. So once again, this is going to be upcoming Monday lesson. That means as is closer to 1, that means they're very, very centered to a linear relation. So that means 0.9 is very close, approximately to 1. You say closely approximate to 1. And more specifically, positive 1. So very strong correlation. We talked about this before, very strong linear correlation. Look at this, literally very beautiful straight line trend in here. And everything is very close to the center of the line. Strong, strong, strong correlation, and positively, because it's a positive one, positively related. All right, so that means that as the x go up, the y goes up. So that's how you explain it. But once again, when you're in the exam, put in beautiful English word. Don't be like me, okay? Next one, quadratic formula. So the quadratic formula is actually being provided at the very end of this reference sheet. So please make sure that you remember right here, right? Very, very clear. And I do remember it by heart, but you should remember it by heart in the future for your own good. So it's negative b, positive negative square root, b squared minus 4ac, and divide by 2a. What are they? Here, the coefficient is 1, so a equals 1. Here, coefficient is 4, so b equals 4, and here, coefficient is -3, or technically the constant is 3, so we're going to say c equals -3. And all you got to do is just plug in. So I plug in, so a negative of a 4, positive negative square root, b squared, which is a 4 squared, minus 4 times a is 1, times c times a -3. Over 2a, so 2 times 1. And you plug in yourself. -4, positive negative square root 16 minus positive 12 over 2. Yourself again, -4, positive negative square root of 28 over 2. So this is already good enough answer-ish, but once again, they want a simplest radical form. So our radical is not done yet because you can have a 4 times 7 into a 28 because that's our greatest perfect square already. So you can factor it out. It's -4, positive negative of a 2 square root of 7 over 2. Once again, if you simplify that, you will have a -2. And then plus square root of 7, and also -2 minus square root of 7 as a final answer. Okay? So that's how you have those two simplest radical form. Once again, get used to calculating for radicals. We have done it since September. Very, very, very long time ago, but trying to remember that for your own good as the regions comes. Next one, solve the system algebraically. Now, listen up. These are very hard questions, but if you know how to solve it algebraically, you will get a full score. But if you don't know, please punch in the decimal graphing calculator, get as much point as you can. Y equals x squared minus 7x and then plus 12. That's 1. Oh, sorry, x. Good enough for the equation. And the next one is y equals 2x minus 6. Now, bring it back to the center. You actually do see this is the point, and this is the point right here. You'll have something looking like that, which is very, oh, sorry, there's an 8. Oh, my goodness. 7. There we go. You have some beautiful point right here. So if you use decimal graphing calculator, and you don't technically know how to solve it algebraically, so if you use decimals, this is a 4 points in total. But if you did not show anything and you say that I use a decimal graphing calculator, I have a 3, x equals 3, and x equals 6, but once again, x coordinate only. And then you got 2 points in here. Once again, in regions, you're trying to just get as much point as possible, so you already own 2 points. You already have 2 points in here. All right, but sad thing, there's 4 in total. But I'm going to show you how to do it algebraically. Once again, this is by substitution. I have y equals x squared minus 7x plus 12, and the other one's y equals 2x minus 6. Since these are all having y isolated, so you can replace one of them, doesn't matter which one's which, so you set them equal to each other directly. All right. And then you do just like properties of equality, pushing everything on one side. So minus 2x and then plus a 6. All right, and then here you have x squared minus 9x. Ooh, this is, there we go. Square minus 9x and then plus an 18. That equals 0. Now, there are things that you have done already back in December and October. Sorry, September and October, which is called the AM and the AC method. You have seen this before. Things that multiply into 18 that will add up to a 9, which is specifically a 3 and a 6. So you can do a chart like that. You can say, oh, whatever, that is multiplied to 18. 1, 18, 2, 9, 3, 6, and then the other way around. Whatever add up to -9. Does it add up to -9? No, not really. And actually also the negative signs. So negative, 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 negative. So you have a -19, -11, and -9, which is right here. So that's how you factor it out, x minus 3 and also a x minus 6. And then when you solve it, when you set this x minus 3 equals 0, and then individually x minus 6 equals 0, then you have x equals 3, and then x equals 6 individually. And that's how you solve it algebraically by factoring. Okay, this is how you do it by factoring. All right, I'll give you some time to bring back your memory. All right. Next. This is finally the last part, which contains 6 points in total. Okay, Anna spends $30 on balloons party and half for a daughter birthday party. Okay, this is very classic systems of equation. $30 on balloons and hats together. Hats and balloons, $30. And then including balloon is $2 each and the hat is 1.5 each. And then needs twice as many the number of balloons. This is a very classic system of equation. Just like before, you open up a parentheses. All right, write out every single relationship. You know that the balloon is $2, so this is a $2. And then times the amount. You don't know what's the amount of balloon, but they say that the amount of balloon is X. So I'm going to say X. And, which is plus, the dollar of 1.5, which is a dollar for your hat. Again, the amount. So you times, I don't know what it is, but they said use the letter Y, so Y. They said together is a $30. So once again, just like before, this is the total amount of money. If you bring back to the previous page, they'll look exactly the same. Once again, the dollars amount equals to total. Look, this equation repeats over and over and over. And the other one have to be amount added together or some kind of amount relationship. All right, so in here they said the number of hat, so the y, the hat is so equal twice as many, so 2 times the number of balloon x. So y equals 2x, just like that. They said write the system equation, and then I bet the next page is for you to graph it and then solve it. Yep. So in here, they only says write the system equation. You don't technically need to solve it, so I'm going to leave it that way. And then next one, square graphing. Always, you have the decimals graphing calculator. If you want to, you can do it by hand, but nobody wants to do it by hand. 1.5y equals 30. And then the next one is y equals 2x. All right, so you have this. Let me bring it back to home so then you can have like beautiful cross points. And then the other one there. So they said graph the system equation. Okay, I got points. I got 0, 0. I got 6 comma 12, which is right here. Right here. And then I got 15 comma 0, which is right here. So I should use a ruler. Once again, pay attention, use a ruler to graph this. And let me bring it up a little bit and see where does it cross? It crosses 20. So I'm gonna cross a 20 and there we go. It's ugly, but there. And I cannot go to 0 because I don't have a negative amount of hat or any of the gifts that they got buying. So state according to the points of intersection, and you do see it in the decimals graphing calculator, which is 6 comma 12. So all you got to do is write it down. And this actually do worth 2 point, I think. And this also worth 2 point in here. And the last one says that explain each coordinate means. What does that mean? All right. So 6 comma 12 is when both equation are being satisfied. All right. And then 0 comma 0 is the x and also y intercept of the the second equation of a amounts relationship. And then we can also mention 15 comma 0 is going to be when you have 15 balloons and 0 amount of party hats, you still fit the budget. But you can also mention 20. 0 comma 20 also fit the budget. These are 2 extreme cases that you will have everything fit the budget, but that's not a nice number. Only 6 comma 12 is when it satisfies both. The amount is good and also the budget is good. Okay, so that was the last question. Ta-da! Okay, so I'm going to stop the recording here so you can take a look and study for it. I'm also going to post this online. So far today, nobody joined, but still I'm going to post it in Google Classroom and have a wonderful weekend.